All right. Well, it turns out that all we need to know are the derivatives of sine and cosine, and we can figure out the derivatives of all of the other trig functions. Okay, because we can express any trig function in terms of sine and cosine. So tangent of x is sine of x over cosine of x. And if we want to find the derivative of tangent of x, we can just use the quotient rule. So let's do that. We're going to find the derivative dx of tangent of x. All right. So we're just going to use the quotient rule. Again, you could make a box if you want to, right? You have sine of x on top and cosine of x on the bottom. And the derivative of sine is cosine, and the derivative of cosine is a negative sine of x. Okay, but I'm just going to do low d high. That's my preferred method, is low d high minus high d low over low squared. Okay, so low d high minus high d low. Okay, so now this I'm multiplying by a negative sine of x, so I'm going to make this into positive, right? Because I'm subtracting a negative, right? And then, boom, all over cosine of x, low squared, right? I'm going to write cosine squared of x. All right. Now, cosine of x times cosine of x. That's cosine squared of x. And sine of x times sine of x is sine squared of x. All over cosine of x, cosine squared of x. All right. Now, we can simplify that even more, right? Because you should recognize the numerator. The numerator you should definitely recognize. It's the Pythagorean identity, right? This holds for any value of x, right? Let me write it over. I'll write it over here. Pythagorean identity. Okay, it just says that sine squared of theta or x or whatever the variable is. We'll just use x since this is x. Cosine squared of x equals 1. All right, that's an important one to remember, is this Pythagorean identity. So notice this is cosine squared plus sine squared, but addition is commutative. We can add things in any order. 2 plus 3 is the same as 3 plus 2. So this whole numerator is just 1, right? This sine squared of x plus cosine squared of x is 1. So we end up with 1 over cosine squared of x. All right. But remember that secant of x is equal to 1 over cosine of x, right? So if I square both sides, I get secant squared of x is equal to 1 over cosine of x squared, but 1 squared is 1, and then cosine squared is cosine squared. Okay, so that's the other thing I'm going to use, is that 1 over cosine squared is secant squared of x. And now we have a new result that we can just use if we need to. We don't have to derive it every single time. Now we've derived it in general. The derivative of tangent of x is secant squared of x. Now we could do that for more trig functions, right? Because we've done sine and cosine, we've done tangent, we could do cotangent, we could do secant, we could do cosecant, right? We have 6 trig functions, and we could do a similar thing for all of these, right? Just using the quotient rule. And we'll do another one in class. But in the end, you have these results, okay? These are the results. These are all of the trig functions: sine, cosine, tangent, cotangent, secant, cosecant, all of them, and their derivatives, and now we can just use them. Now, So that means memorizing. It means memorizing those because you don't want to have to do it. You could derive these every time. And honestly, I sometimes forget, some of these because I don't use them that often, like cosecant. I always have to think, and sometimes I just go and derive it because I can't remember what it is. But I would say the important ones to memorize are going to be, well, definitely. Let me get bigger marker here. So definitely the cosine or the sine, right? And the cosine. You gotta remember those. But other than that, I would say the main thing to memorize is the tangent. That one gets used a lot. Okay. And so that one could appear on a quiz or a test. But the others, I would say, they're nice to know they exist, right? I sometimes even have to look them up because I forget. I forget. Now, the secant is a good one too. That if you might want to memorize the secant is secant times tangent. But yeah, like I said, these three are the main ones. So now we just get to use them. So I'll meet you in the next video, and we'll look at these next two examples and use these trig derivatives. All right.